Hello and welcome to today's lesson. So, for now, let us look at asymptotes. And we must know that there are three types of asymptotes, yeah? So we have the vertical asymptotes, we have the horizontal asymptote, and we also have the oblique asymptote, which is also called the slant asymptote, yeah? So asymptotes are simply line on your XY plane that your graph will never touch. All right, it will just run infinitely parallel to it, but it will never touch or cross your asymptote. So for example, I can have my graph like this. This is my XY plane, and then I'll have my asymptote there and my asymptote there. So the behavior of my graph will be such that if my graph is lying somewhere in this region, my graph will always go infinitely with the asymptote and to never cross this asymptote or even touch it. Yeah, so that's the basic idea of what asymptotes are. So getting deep into these asymptotes, we'll start with the vertical asymptotes. So vertical asymptotes, yeah, so from the vertical, we understand to say the vertical meaning that in this orientation. All right, so these vertical asymptotes can be found from a rational function. Let's say we have one that says f of x plus 2 over x minus 1. The vertical asymptote is simply found by setting your denominator equal to 0. All right, so here we can have the denominator here is x minus 1. You equate it to 0 and then you solve for x, so it's going to be x equal to 1, meaning this one is your vertical asymptote. So if you have your graph like that, you would have a point 1 there, and that is where your vertical asymptote would pass, like that, dotted. Yeah, and then you can also have something that says what? You can have f of x is equal to 2x squared minus 1 over maybe x squared minus 4, like that. Yeah, so setting the denominator equal to 0 would have something that says x squared minus 4 is equal to 0. Therefore, we would have something that says x squared is equal to what? 4. So this would be the root on both sides, where x will give us the positive or negative of 2. So in this case, we'd have two vertical asymptotes where x can be equal to positive 2 or x can be equal to negative 2. So representing this on your xy plane would be as follows. All right, the positive 2 and the negative 2 on your xy plane. So we'd have your xy plane like that. Yeah, xy plane, and then you would have your positive 2 there, and then you would have your negative 2 there, and then you would have your two vertical lines that are going to come like that, dotted, and another vertical line that's going to come like that, dotted. So these are your vertical asymptotes. Set your denominator equal to 0 and you have your vertical asymptote. Hope we're good. Next up, we have the horizontal asymptotes, HA. Horizontal asymptote is simply found by looking at the behavior of your x. Alright, so if we have f of x is equal to x plus 1 over maybe 2x squared minus 2. Yeah, so let us think of these x variables maybe as mighty men in a village of algebra, right? Yeah, so we can say these x variables are going to war. So we have a village at the top and a village at the bottom, and then these powers, the powers that these guys have, are more like ranks. All right, so the one with the highest power is one with the highest rank, meaning he's the most powerful. So if they are going to war, the top village would send the man with the highest rank, which is the highest power. The bottom village would also send a man with the highest rank, meaning the highest power. And then when those guys with the highest ranks go to war, they will battle, right? So in this case, we have what? X to the power 1, and then also have x to the power 2. Now we get to see that the power on top is less than the power at the bottom, meaning the rank on top is less than the rank at the bottom. So obviously the bottom would win. So your horizontal asymptote is going to be y is equal to 0. Yeah. So when your bottom village wins, your vertical asymptote is always y is equal to 0. Now on your x or y plane, let me put up an xy plane right here so I can say this. If this is my xy plane, This is my x-axis, and then this is my y-axis. So the line y is equal to 0, which is horizontal, will typically be in the x-axis like that. So we can basically say this line y is equal to 0 is just the x-axis. Therefore, we can also say that if the highest power of x at the bottom is greater than the highest power of x at the top, therefore your horizontal asymptote will always be y is equal to 0. Always. Yeah. Now, what if we have it in this case? So we have x plus 1, x minus 1. So we need to focus on the highest power of x at the top and the highest power of x at the bottom. So here we get to see that these guys both have equal ranks, right? Equal ranks, power 1, power 1. So in this case, what you get to do is that you get the coefficients of the highest, of the x that has the highest power. So in this case, it's going to be 1 over 1. Therefore, this is our y is going to be equal to 1, meaning this 1 is our horizontal asymptote. Yeah, so if we have our xy plane like that, we would have a 1 somewhere there, and then our horizontal asymptote would pass at that point 1 there. So we can have another example that says what? We can have another function that says f of x is equals to x squared plus 2 x minus 1 over x squared plus 4. Yeah. So in this case, let us try finding both the vertical asymptote and the horizontal asymptote. So setting the denominator equal to 0 will make us find the vertical asymptote. So we're going to say x squared plus 4 is equal to 0. So it's going to be x squared is equal to negative 4. Now, if you introduce the root on both sides, you're going to notice that you're going to have a root of a negative number, and this is going to give you something imaginary. It won't give you a real number. And on our xy plane, we only deal with real numbers, therefore imaginary numbers are not accepted. So here you can conclude by saying we have no solution for the x. Alright, no solution for the x, meaning we have no vertical asymptote. Simple as that. So that is your conclusion. You have no vertical asymptote because you're unable to find a real solution for the value of x when you set the denominator equal to 0. Good. Now let us go to the next one, which is the horizontal asymptote. Horizontal asymptote, you look at the behavior of your highest power of x and your highest power, at the bottom and at the top. So here we have two men at the top. So the first man has a ranking of 2, the second man has a ranking of 1. So going to, I would rather pick the man with the highest ranking, which is that of the power 2. So we would consider this one here, and then it would be over under here we have x to the power 2 as well. So getting the coefficients of this, so there's 1 here and there's 1 here, so this is going to be 1 over 1, therefore our y is going to be equal to 1. So this is our horizontal asymptote. Yeah, so you'd have something like this. There was this 1, and then you have a horizontal line passing there, and no vertical asymptote, so you're good to go. We can also have another scenario where we have what? Where we have f of x being equal to something that's just like 2x power 5 plus 1 over maybe 3x plus 4 minus 4x power 5 plus 3. Yeah. So in this case, let us find the horizontal asymptote. Check in. The highest power of x at the top is what? X power 5. The highest power of x at the bottom is also x power 5. But these guys have coefficients, right? So this one has a coefficient of 2, this one has a coefficient of negative 4. So here what you're going to say is that since they both have equal rankings, you're going to get the coefficients, yeah? So you can think of the coefficients as their wives. You know, when men of equal caliber meet and they're unable to defeat each other, they'll call the wives to help them. So these are the coefficients. This is going to be 2 over negative 4. So this is going to be 1 over 2 negative. So y is equal to negative 1 over 2 is going to be our horizontal asymptote in this case. Yeah. So the vertical asymptote would be setting your denominator equal to 0. And well, good luck with that. Yeah, so that is how you find the vertical asymptote and the horizontal asymptote. As simple as that. Now, in a case where you have f of x is equal to x squared plus 3 over x plus 1, yeah? So what do you notice here? the highest power of x on the top is greater than the highest power of x at the bottom. Yeah, so in this case you have no horizontal asymptote. As simple as that. You have no horizontal asymptote. Horizontal asymptote only comes about if the powers of x at the top and at the bottom are either equal to, or the one at the top is less than the one at the bottom. Alright, top less than bottom, or top equal to bottom. This is the only times when you're going to have a horizontal asymptote. But in a case where your top is greater than the bottom, then there is no horizontal asymptote. But in this case, you're going to have an oblique asymptote. Oblique asymptote, which is also called aslant asymptote. Either of the two works out. So top greater than bottom, no horizontal asymptote, but oblique asymptote. So we're going to look at how we work out with our oblique asymptote in the next video, but for now, let's just know these two, vertical and horizontal. So you can go and practice more questions on these, and that was it for today.